The quest for clean energy solutions is more urgent than ever. Climate change demands action. Renewable energy sources are vital to this fight. Among these, solar power is a beacon of hope. But land for large solar farms is often scarce. Competition with agriculture and urban development is fierce. This is where floating solar farms emerge as a game changer. Imagine this: vast arrays of solar panels, not on land, but floating gracefully on water bodies. This innovative approach offers a new frontier for solar energy. It unlocks the potential of untapped spaces. Lakes, reservoirs, and even oceans can be transformed. They become sources of clean, renewable power. Floating solar farms are more than just a technological marvel. They represent a paradigm shift in our energy strategy. They represent a commitment to a sustainable future powered by the sun. The concept is simple yet powerful. Solar panels are strategically mounted on floating platforms. These platforms are designed for stability and durability. They are moored securely on water bodies like lakes or reservoirs. The panels absorb sunlight, converting it into electricity. This electricity is then transmitted to the grid via underwater cables. The water beneath provides natural cooling for the panels. This enhances their efficiency compared to land-based installations. Floating solar farms offer a practical solution to land use constraints. They can be deployed in areas where land is scarce or expensive. They can coexist with existing infrastructure such as hydroelectric dams. This maximizes energy generation from a single location. This technology is gaining traction worldwide, from sprawling mega projects to smaller community-based installations. Floating solar is making its mark. It's a testament to human ingenuity in our pursuit of a sustainable future. Floating solar farms offer a compelling set of advantages over their land-based counterparts. These innovative installations are not only a marvel of modern engineering, but also a testament to our ability to adapt and find sustainable solutions. The most immediate benefit is the efficient use of space. In urban areas where land is at a premium, floating solar farms provide a viable alternative to traditional land-based solar installations. By utilizing water bodies, they avoid competition for valuable land resources. This is especially important in regions where land is needed for agriculture, housing, and other essential uses. This is particularly crucial in densely populated regions. In such areas, every square meter of land is precious, and floating solar farms help alleviate the pressure on land use. The cooling effect of water further enhances efficiency. Solar panels tend to lose efficiency as they heat up, but the water beneath them helps keep temperatures down. Solar panels perform better at lower temperatures. The natural cooling properties of water ensure that the panels operate at optimal efficiency, even during hot weather. Water's natural cooling properties help maintain optimal operating temperatures. This cooling effect can lead to a significant increase in energy output over the lifespan of the solar panels. This translates to higher energy yields compared to land-based installations. The increased efficiency means that floating solar farms can generate more electricity from the same amount of sunlight. Floating solar farms also offer environmental benefits. They provide a dual purpose use of water bodies, generating clean energy while preserving the ecosystem by covering a portion of the water's surface. They reduce evaporation rates. This is particularly beneficial in hot climates where water conservation is critical. This is particularly valuable in arid regions facing water scarcity. Reducing evaporation helps maintain water levels in reservoirs, ensuring a steady supply for communities and agriculture. The shade provided by the panels can also help control algae growth. Excessive algae can harm water quality and aquatic life, so the shading effect is a significant environmental benefit. This improves water quality in reservoirs and lakes. Cleaner water benefits both human populations and wildlife, creating a healthier ecosystem. Furthermore, floating solar farms have a minimal visual impact. They blend seamlessly into the water, preserving the natural beauty of the landscape. They are less intrusive than large-scale ground-mounted solar installations. This makes them an attractive option for areas where preserving the natural scenery is important. They can be integrated aesthetically into the surrounding landscape. The design of floating solar farms can be tailored to complement the natural environment, making them more visually appealing. This makes them a more acceptable solution for communities concerned about visual pollution. By addressing both energy needs and aesthetic concerns, floating solar farms represent a harmonious balance between technology and nature. Section 4, Case Study, a look at global floating solar projects. In this section, we will explore some of the most innovative and impactful floating solar projects from around the world. Around the world, floating solar farms are demonstrating their potential to revolutionize the renewable energy sector. These projects are not only innovative, but also offer unique solutions to land scarcity and energy needs. One notable example is the Yamakura Dam project in Japan. This project has set a benchmark for other floating solar initiatives globally. Completed in 2018, it was the world's largest floating solar farm at the time. The project covers a significant area of the dam's surface, optimizing space that would otherwise be unused. It boasts an impressive capacity of 13.7 megawatts, enough to power nearly 5,000 homes. This capacity highlights the potential of floating solar farms to contribute significantly to local energy grids. Another groundbreaking project is located in Huainan, China. This project is particularly notable for its scale and the innovative use of space. This massive floating solar farm spans an area equivalent to 300 football fields. The sheer size of this project demonstrates the scalability of floating solar technology. It generates a staggering 40 megawatts of power, showcasing the scalability of this technology. This project serves as a model for other large-scale floating solar farms around the world. In the Netherlands, a floating solar farm on a drinking water reservoir exemplifies dual-use applications. This project is a prime example of how floating solar can be integrated into existing water infrastructure. It generates clean energy while simultaneously reducing evaporation and protecting water quality. This dual benefit makes floating solar an attractive option for regions facing water scarcity. These are just a few examples of the global momentum behind floating solar. The increasing number of projects worldwide indicates a growing recognition of the benefits of this technology. As technology advances and costs decrease, we can expect to see even more ambitious projects emerging in the near future. The future of floating solar looks bright, with the potential to make a significant impact on global renewable energy production. Section 5, Innovation in Action, Advancements in Floating Solar Technology. The field of floating solar technology is constantly evolving, driven by the need for sustainable and efficient energy solutions. Researchers and engineers are working tirelessly to improve efficiency, durability, and cost-effectiveness, ensuring that these systems can withstand harsh environmental conditions. One area of focus is the development of new materials for floating platforms, which are crucial for the stability and longevity of these installations. Traditional platforms are often made of concrete or steel, materials that are heavy and can be costly to transport and install. New materials like high-density polyethylene or HDPE offer significant advantages in terms of weight, durability, and recyclability, making them an attractive alternative. These lightweight yet robust materials reduce transportation and installation costs, making the deployment of floating solar farms more feasible and economical. Another area of innovation is the integration of smart technologies, which enhance the functionality and efficiency of solar panels. Advanced monitoring systems are being incorporated into floating solar farms, allowing for real-time data collection and analysis. These systems use sensors and data analytics to optimize energy production, ensuring that the solar panels operate at peak efficiency. They can detect and diagnose faults remotely, minimizing downtime and reducing the need for on-site maintenance. Furthermore, researchers are exploring the potential of bifacial solar panels, which represent a significant advancement in solar technology. Unlike conventional panels that only absorb sunlight from one side, bifacial panels can capture sunlight from both sides, increasing their efficiency. This increases energy yield, especially in water environments where sunlight reflects off the surface, providing an additional source of light for the panels to capture